Crowded particles, the physics behind moving faster in a crowd. Particles that speed up in a crowd? It's not what you'd expect, but that's exactly what physicists at Leiden University discovered. They found a new state of matter where particles gain energy from collisions, moving more when packed close together. We're used to crowds of people or traffic jams slowing down when it gets too crowded. Scientists have mostly studied these kinds of situations where groups slow down when they get too close. But what if the opposite happened? What if particles moved more when they were packed together? That's the question that hadn't been studied much until now. Physicists Marine Leblay, Joshua Saldi, and Alexandra Morin from Leiden University research the collective behaviors that emerge when large groups of particles are packed together in the field of active matter physics. In their experiments, they used tiny, non-moving particles, 1 millimeter metal beads, placed between two glass plates that were also electrodes. When they charged the beads with electricity, they started jumping up and down, moving back and forth between the plates extremely fast, around 100 times in 1 second. This gave energy to the system of beads. They took 300 to 400 images per second with a high-speed camera, then made slow-motion videos to discover in detail what was happening. They linked every particle from one image to the next and made precise statistics of the movements observed. With only a few beads, nothing surprising happened. But when they increased the number of beads to hundreds and thousands, the beads started moving around wildly, forming a very dynamic and disordered system, an active gas state of matter. The researchers discovered that the particles bump into each other in a very special way, with super elastic collisions. Instead of losing energy like a bouncing ball eventually coming to rest, they pass energy on to each other during these bumps, which triggers more movement. So, the more particles, the more collisions happen, and the more active the whole system becomes. Once they understood this, they realized they could control the collective behavior of the metal beads by powering them intermittently, switching the electric field on and off. The faster the switching, the slower the movements. And the structure of the group also changed. They could obtain structures analogous to gas, liquid, and crystal states by simply turning